And let's start with a big question that's important and kind of a prerequisite for talking about what DBT is, which is talking about who and what this workflow, this modern approach to analytics into the modern data stack actually is. So normally in the course, this is the part where I ask the folks who are here to go around and introduce themselves. I'm just going to introduce myself and say, again, my name is Jeremy. I'm an associate product manager at Fishtown Analytics, formerly analytics engineer, course instructor, bunch of other things, lots of hats on the hat shelf. So I and a lot of us at the company have been practitioners of modern analytics for many years, and DBT grew quite naturally out of that. It was not like the egg that then hatched the chicken. It was very much us raising chickens and then realizing we wanted to apply the principles of software engineering to egg farming. Maybe not. Anyway, I'm calling from Philadelphia, Pennsylvania in my bedroom. I'm sure you all are calling from some version of that yourselves, as it's been for several months. The traditional data team, as we see it and as we experienced it in a lot of past jobs, experiences, consulting engagements, has been one of data engineers and data analysts with an explicitly separate, at times even antagonistic relationship, where data engineers are responsible for writing all ETL, all infrastructure management, and needing to transform data, by definition of the ETL stack, transform data in advance of loading it into some final exposure layer, some relational database like Postgres that analysts can then access it. The role of data analysts being to write SQL, to take stakeholder requests and translate it from English into SQL, or from French or Spanish or whatever other language into SQL, using that SQL to then power dashboards and reports or any downstream insights work that they need. But if there are problems with that data, if there are new columns that need to be added, new business logic that needs to be defined, it requires filing a ticket in very much the same vein as it would if the pipes broke, or if data isn't fresh, or any of the other things, any of the infrastructure needs to be upgraded or scaled up. These are all falling into the same category of issues that just need to be thrown over the wall, thrown over the garden fence from the data analyst team to the data engineering team. And these two groups of people don't necessarily report to the same person, the same team, the same function. They might be down the hall from each other, but they might just as equally be in different states or countries around the world. And of course, the role of the stakeholder is just to patiently wait while their English language or other human language requests are being translated into SQL by analysts who then need to throw them over the wall to the engineers. So this is not rapid iterative analytics, and it can't be on a structural level. And there were real technical and technological reasons for this 5-10 years ago, reasons that an ETL stack is necessary. But with the advent of the modern data warehouse, with Google BigQuery, Amazon Redshift, now Snowflake as well, it's just not as necessary from a technical standpoint to transform all data before loading it into the warehouse. We sit on top of the shoulders of giants, in particular on top of an all-powerful supercomputer that can handle storing multiple copies of the same data over and over again with meaningful transformation applied on each layer. So for anyone who's particularly observant, you'll see that I've badly cropped out something in the middle here. This is using my student license to Adobe Illustrator that I still managed to keep around for a little bit. Data is loaded in by some external third-party tool. Good. Maybe it's Stitch, maybe it's Fivetran, maybe it's something else. Maybe it's custom ingest if absolutely necessary. That's where the data engineering team still serves a vital function. It arrives as what we call raw data, source-conformed data in the warehouse. So it is not structured in such a way that may make sense to the business. It is structured in a way that makes sense to Stripe's API engineers or Zendesk's API engineers or Stitch and Fivetran writing the ingest for those. If we just directly plug that into downstream use cases, to BI, to reporting, to whatever our ML engineers get to work on every day, there are going to be some problems. And those problems look like having 2 or 3 or 5 stakeholders with different values for a KPI because they've defined it just marginally differently. Or even if conceptually they've defined it the same, maybe they've just forgotten a little bit of that magic reusable logic that needs to go everywhere. We need to ignore canceled orders, of course, but also somehow false orders. Who knew that orders could even be true? And they can't be deleted, right? But this is null, otherwise timestamp. Okay, good. Oh, actually, one of our QA people has user ID 12, and they just go in and try to break a bunch of things all the time as often as possible. Maybe it's even the CEO on the weekends, so we need to ignore their orders as well because that's noise. If any one of these is something we forget to write in every single dashboard or report or ad hoc query that we pull for our the person who sits down the hall from us, we're going to end up with a wrong number in the sense that we'll end up with a different one from everybody else's. That's putting aside the just good old-fashioned SQL things we can do to get a wrong number, like accidentally fanning something out because we thought it was 1-to-1 when it turns out it was 1-to-many. Or because the data is missing and it's Monday morning, it hasn't ingested since Thursday afternoon. Or kind of the most dangerous and subtle answer of all, which is all the dashboards work, all the reports run, all the queries seem right, but we have no idea how the data actually gets there and how it gets from the warehouse into the email inbox of our CEO every Monday morning. So I see this one as the scariest yet, which is everything works and we don't know why. Feel free to chat in if any of these experiences resonate with you. If not a single one of them does, I would say you live a charmed life and I envy you for it. So you can see this is the same image from before without my bad crop job. There are a couple of key pieces that need to sit in the middle, that need to sit in between raw data, source-conformed data, and something that's actually transformed to be business-conformed, to be ready to be have the same meaningful definitions applied in modular and reusable ways. And there are a lot of steps that go beyond just transformation, that go beyond just writing the SQL select statements to take orders and return the orders that we actually want. We should be testing those transformations, as well as testing our source data that feeds into those transformations. We should be deploying those transformations in an automated and scheduled basis. We should be documenting those transformations so that if, as does naturally happen, the really talented analyst who built a lot of our infrastructure from the ground up, built a lot of our transformation logic, ends up leaving to go pursue a life of the arts, we're not totally at a loss because the logic has been documented in human readable language. Maybe we need to add some pieces on the other end. Maybe we need to snapshot slowly changing dimensions so that we're not losing important contextual information, and to be doing the whole thing in version control with alerting and logging along the way. These being, in some sense, the principles of software engineering, the recognition being that SQL is code. There are things that people do in the world to build, maintain, and quality assure code. We should be doing those things too. Now, I should say it is 100% possible to do every single one of these things and never have heard of DBT or written a single line of DBT code, to have never typed DBT run into a terminal. Our vision for DBT is that it is a piece of open source software that encapsulates this workflow, underpins it, and is reinformed by it. So as we get better, at thinking about how to snapshot slowly changing dimensions within the warehouse. We feed that better back into DBT. And indeed, members of the community, a couple of whom are on this call right now, have been so kind as to contribute it back because we sit on each other's shoulders as well as the shoulders of a supercomputer. So the ability to capture hard deletes in snapshots has long been a conversation in the community, fed back into pull requests and into code. A lot of this is articulated in the viewpoint, which you can read in our docs here, but also probably easily Googleable. So with all of this comes a notion of the analytics engineer. And this is a little bit of a neologism, but it's also a little bit of a recognition of there is work that the canonical data analyst may not be ready for, or more often may not be interested in. At the same time, there's a set of incentives and responsiveness that traditional data engineering teams just have not been aligned with or are not reactive to in the way that they should be. So someone who sits in between the work of the people who partner closely with members of the business and people who sit a little further back in the office, maybe doing important work around infrastructure provisioning and building custom ingestion. Let's talk a little bit about the fundamentals of DBT, and let's do it using an example that you all can do on your own computers with your own BigQuery accounts, if you'd like, your own DBT Cloud developer accounts. So this is familiar for anyone who's been around the community for a bit. We talk a lot about jaffles. Jaffles are a kind of sandwich, though they're also much more than that. I'm an analyst working at the Jaffle shop. We have customers, we have orders. This exists in a Snowflake warehouse that I have access to, but critically, it is also available as a set of public S3 files and a BigQuery public data set. So if everyone wants to, on their own time or right now on your own computers, go to docs.getdbt.com, getting started tutorial. This is going to walk through a little bit of how to set up your own BigQuery account, how to set up your own DBT Cloud account, that you can certainly also install DBT on the command line and use it there. You can install it using Homebrew if you're on a Mac, or pip, or install from source, though I probably would recommend pip. It's a Python program. And we've got a query that we can play around with. I'm going to play around with it in Cloud. So this is a query that takes customers and orders, joins them together, finds each customer's first order date, most recent order date, number of orders. And it's about 56 lines long, which is, not too bad as things go. But still, there's a lot going on here, probably more than needs to be all at once. This is what I get after it when I run this query. Number of orders, most recent order date, first order date. And what I want to do is take this magic SQL, and rather than just save it as a .SQL file on my desktop and then keep it in a special folder called, indispensable, because it's all the things that make me indispensable at my company, I'm actually going to modularize it, push it to GitHub, make it shareable, make it collaborative, make sure that other people in the world can access it. So there's a couple steps to do here, and let's talk about them. First off, what's the benefit for transforming my data at all? Well, maybe you notice some weirdness around the user ID column in orders actually mapping to the ID in the customers table. Who knows exactly why that is? Maybe it was initially a table of users. Maybe we had a notion of users of my Jaffle ordering app before we had a notion of customers, of people actually paying for and buying my sandwiches. There are some useful fields that I need to build up. And at some point, I don't want people to have to write the same join logic over and over and over when I know that they're going to need some useful recapitulation of orders and customers every single time. So I can connect the BI tool directly to that transform data. Here's how to do this manually, and Claire gave a good example here. It involves writing DDL. Create table, dev Claire, or in my case, create table dbt Jericho dot fact customers as. All right, should work. This is going to run against Snowflake. I'm pretty sure that that's the syntax, and I'm pretty sure that it's right. All right, that works well enough. But let's say I actually want it to be, I don't know, a view now. I know my data is always updating. I want it to be always up to date. All right, it's an error. Well, it already exists as a table. I would need to know that I need to drop table first. And actually, does the schema already exist? In this case, I lucked out and it did. But if it didn't, I would need to create schema dbt Jericho. Well, but I want to run this, and I also don't want it to error if the schema does already exist. So create schema if exists. Anyway, I'm belaboring a point, but this is boilerplate code. At least we see it as such. There's a talk right after this by some folks from Stitch Fix who I admire greatly and have read their work. And one of the more famous bits they put out in the world was engineers shouldn't write ETL. We also believe engineers shouldn't write DDL, analytics engineers, that is. As much of this boilerplate code as we can avoid writing, we should. And so instead of writing that and handling all these cases, we're going to use dbt. So what do we need to use dbt? Data warehouse, good. You all, anyone in the world can spin up a free BigQuery account. Can also spin up a Snowflake trial. Could also spin up a Postgres database locally. That's all you need. Just needs to be able to run SQL with data already loaded into it. Now, Postgres, Snowflake, BigQuery, Redshift, these are not the 4 databases in the world that can run SQL. They are just the 4 that are defined as core adapters within dbt. We're going to talk much later today about what it looks like to use databases which are not in those core 4. It's totally possible. All you need is a data warehouse that can run SQL and access data using SQL. You need a dbt project. I instantiated mine right here, just totally from scratch. This is the dbt init function on the command line, or the big green button in cloud. The project needs to have models in it, which we're going to make one in a second. And it's going to have a lot of YAML in it for configuration. So models are just our select statements. No create table as, no insert, no delete, none of the DDL or DML. Those are actually handled in an abstraction layer that dbt gives us. So rather than needing to worry about writing all of that wrapping, I'm actually just going to make a file called customers and hit dbt run. Create a replace view. It's there for me. Let's try to make this even a little trickier for ourselves. I don't want it as a view. I want it as a table. Drop view if exists. create or replace transient table. So as part of that abstraction layer, dbt even knows, hey, I'm running on Snowflake. On Snowflake, I don't want Jeremy to have to worry about paying for storage of all these objects I'm creating and dropping over the course of time. So by default, enable transients. And those are just the kind of things that we know about because we've got a lot of people in the community who have storage costs, realize that turning on transients by default makes a lot of sense. Make it even harder for myself. Okay, I have no schema. I've got it now, and it just works. So dbt needs to be able to connect to the warehouse. I took a little bit of a digression there, but that's okay. Fair enough. On the CLI, this looks like making a file called profiles.yaml in a hidden directory, just so that you're not checking any credentials into Git. In Cloud, it looks like adding that same kind of credentialing information in the UI. And then the command. As you've been seeing, I've been running dbt run. Can also make this a little more particular. Just run my customer's model. Here, that's going to have no effect. I've got one model, but all the same. I'll talk a little bit later about all of our new and great ideas for how to make that even more powerful. Fair enough. So dbt connects, parses my project, wraps all my models in the DDL that's needed based on the state of the database, executes the code to build all those models into my target schema. In this case, it's dbt Jericho, me. But I could set this up to, in production, run with a totally separate schema. And that's the way that dbt is environment aware. And we're able to separate between development, my development, your development, someone else's development, staging, CI, production, always having control over where dbt's assets are going to end up. I've already been showing you a little bit about this, but how to see what's going on. We've been looking at some of the debug logs, some of the details here in the run status. Broken down by model. So this is the SQL that dbt is actually running against the database. This is Jinja, it's a Pythonic templating language, which we use to configure and extend the SQL that we run and that we write. I could also pop into my logs file here, or this git ignored target directory to see just what I've got for my customer's model, and then the actual SQL that's run. So there's lots of ways to figure out what's going on. None of this is meant to be obfuscated. It's all meant to be transparent, but also in a way where I don't need to worry about it unless I absolutely have to. We talked about this a little bit. I added the config materialized. There are 4 materialization types that dbt knows about by default: view, table, ephemeral, incremental. There are many, many more which you can write yourself, which people out in the world have written themselves. These are, again, parts of the constructs that dbt ships with, but then are extensible because it's meant to be a framework, not a tight, like so tight a view of the world that there's no wiggle room. So as I said, materializations, build strategies. Analytics engineers shouldn't write DDL except when they write it functionally. Write it once, use it over and over again, and no need to write it if it's just create table as. And then configurations are model settings, ways of adjusting and adapting that behavior. So like materialized, or like the ability to tag things, enable them, turn them on or off. I could also, for instance, turn off the transients of my tables if I got the SQL right. Probably not. I mean, not the SQL, I'm sorry, the configuration right. Obviously, I should be checking the docs here, but let's just see if I'll get it on a Hail Mary. Nice. No more transients. So again, connect to the data warehouse, parse the project, wrap those models in the appropriate DDL, DML, execute that SQL to build models into the target schema. Now, what about having more than one model? I know that in other orchestration tools, there is a notion of a DAG, of a directed acyclic graph. Acyclic depends how you want to go with that. Greek alpha privative, not cyclical, cannot start back over on itself. What if, instead of this being all here, I actually want to make some new models, make it a little more modular. So now, instead of rewriting that SQL over again, I want to do something to the effect of, like, select from my version of the stage customers model, but then in production, select from, whoops, that's a funny way to, the production version of the stage customers model. Well, dbt's got a construct for that. It's the ref function. It's arguably the most important thing we've got. And this will dynamically compile out to whatever the right version of the model is for the given environment, for the configurations that I've given. Select from ref stage customers. Let's do the same here. Stage orders. Okay, I'm getting a configuration, or I'm sorry, a compilation error down below. Depends on stage orders, but it's not found. Rightly so. I haven't made it yet. Patience. You'll see I'm still statically typing the raw source of data here. We'll get there. Everything looks good. So I've implicitly said that customers depends on stage customers and depends on stage orders. STG here just meaning it lies quite low to the source data, to the raw data. I'm just lightly touching it up. I'm lightly renaming ID as customer ID, user ID as customer ID, ID as order ID. Probably, you know, this is my chance to make the data usable to me, make it named well for the rest of my analytics ecosystem. So magically, dbt just knew stage customers and stage orders need to run before customers because customers is going to depend on those two. Now we call those dependencies the DAG as well. And unlike some other orchestration tools where the DAG needs to be explicitly architected, this depends on this, then run this other thing. Simply by using those ref statements, we know how to compile them out in an environment-aware way, and dbt knows how to create the DAG and then infer from it the order to run models in, so that we can get through it as quickly and reliably as possible. This totally removes the incentive to have hundreds of lines of SQL at a time defined in a given file. So this is a kind of silly example, but when I'm doing laundry, as I do often enough, because the laundry machine is actually in my bedroom in this house, it's pretty funny. I need to not insert quarters, thankfully. I live a blessed life, but at least insert laundry into the machine before I wash it. I need to wash before I move the clothes to the dryer, move the clothes to the dryer, then fold. There's no way to move to the dryer, we'll then insert the laundry back into the washing machine again. One needs to happen before the other. Obviously, this does recur on a, let's say, weekly basis, for being generous, but there is no cycling back. It is directed and it is unidirectional. This is a slightly more complex tag, handling customer acquisition by marketing channel. And this is a real one with real DBT models. And then this is a typical tag for, I believe, our internal analytics project here at Fishtown. Okay. There's a couple more pieces that are important to get through. We'd be remiss to make this a DBT workshop if we don't talk about testing. Rabbi Hillel would say we have not completed the mitzvah of talking about all that is possible in DBT. We've already talked about matzah. This is the maror. What are tests? Tests are assertions that we make that we can define either as arbitrary one-off SQL or more frequently as YAML configurations that then compile to functional SQL which runs against our models. When the assertion is true, the test passes, and it's just a select statement, same as models. So, same as before, connect to the data warehouse, parse the project, iterate through all those resource files, execute SQL for every single test. Could make write some tests. I believe that the customer ID column should be unique, whoops, and not null all of the time. I also feel the same way, whoops, about the order ID column in the stage orders model. And I also feel that, let's indeed rename it, the order status column, order status. Should be one of a set of values that I feel good about. I feel like I understand them, know how to deal with them. Okay, so that's my stage orders model. This is what I actually meant to have typed. Returned, completed, return pending, shipped, and placed. Good enough. I just want to say those are the only values that I'm going to accept. I could write it like this. I could also make it a YAML list. I think that'll work. And then it's just a dbt test command. I've made a bunch of assertions. I've said a bunch of things that I believe to be true. Are they indeed true? Looks good so far. This is how we avoid the situation I mentioned earlier around thinking a relationship, thinking a join is one-to-one, and it turns out it's one-to-many. Well, the primary key that we think is unique in this table would turn out to not be so unique after all. You can see what it looks like when a test fails. Okay. I promise you, what's running behind the scenes is just a SQL statement, value not in my set of accepted values. What happens? Oh, this icon is new. I like that. Oh, summary. We had one failing record. We had one value that is not in the set of values I thought I was willing to accept. Back to the drawing board, or back to figuring out what happened, what went wrong with our data. So that kind of quality assurance, the ability to make assertions and then test them, critical to any transformation pipeline that I'm going to feel good about, because then I can also build these models and run these tests as part of a continuous integration suite anytime I'm proposing changes to my code base, anytime I'm opening a pull request against the Git repository that stores the main branch of my transformation logic, which is deployed and automated on a schedule. Anytime I do that, run all my models, run my tests. Talk a little bit later about smarter ways to go about that. But do both. All green check marks, I feel good about merging my code. Anything red, and we're back to the drawing board. So there's a bunch of helpful commands, especially if you are working on the CLI. Want to be able to check the version of DBT that you're using. We're coming out with new versions every 2 months or so. Just make sure that your connection to the warehouse works the way you think it does. Compile your project. So this is done implicitly by anytime I run or test or do any other commands. There's a couple things that aren't covered in this presentation because we cover them later on in the 2-day course, but I'll talk about them for just a little bit right now, and then open up the floor for thoughts, questions, you all taking a spin at this, maybe me taking a couple of minutes to go get more coffee. So the couple things I want to talk about are ways to establish dependencies for source data as well. If you saw me type this, maybe you're hoping, you're thinking there must be some way to type ref source Jaffle shop customers, maybe, and you'd be really close. It's going to look like this. Source Jaffle shop customers. I'm getting an error down below that says it depends on a source that I haven't yet defined. Hold your sources. Jaffle shop. Oops. Tables. Customers. Orders. Let's do the same here. And I've actually got another node in my dependency graph, in my DAG, which is now sources all the way up to my final customers model. There's one other pretty neat, pretty exciting thing I can do. And I'm going to make sure I get the syntax right here. And that's actually test how fresh, how recent my source data is at having been loaded. If only YAML is, of course, a very indentation aware language. Configuration mechanism, whatever you want to call it. Okay, I've defined a loaded at field for my orders table in particular, and a set of freshness expectations about that field. I think that the max value of ETL loaded at, the last time that records were added to this table, ought be no more than 12 hours from this very moment, 12 hours ago, and it better not be more than 24 hours ago. And there's a command for that. I'm on Snowflake. I set it up in the way that any good Snowflake account is set up, with my raw data in a different database from my analytics data, from my transform data. Okay, I'm getting a warning. It's a little bit out of date. Between 12 and 24 hours ago. Of course, if I realize that's perfectly reasonable, I only run it once a day, I checked in with the data engineers, I checked in with Stitch support, Fivetran support, whomever is responsible for getting this data to me. I revise my expectations upward. Looks good. Or, no, it turns out we do intraday reporting on our orders, so it ought never be more than an hour old and had better never be more than 2, or else we are going to have a skewed view of the day. Well, that expectation is not borne out by the data. Again, this is just a select statement. This is just select max this value from your table. It is something you can and could write yourself, or it's something that you can configure like this. One other piece I want to share is, this is all well and good in terms of writing code and writing code with clarity and hopefully a lot of inline comments. But this is something I hope to collaborate on and share with other people and hand off to others someday. A key part of that, as I mentioned earlier, is documentation, documentation, documentation. So I'm going to put that pizza I just made for everybody in the oven for a second, take out the one already baked. Let's take a look at a deployment run of the demo project we've got here. And view the auto-generated documentation site powered by it. So this has a lot going on, but this is all code, just like the code we were writing, all code that we could write together. We can add descriptions to models and actually push information into the documentation site. The documentation site also pulls a lot of information out of the database. It pulls information, metadata from the project about tags, owner, columns, data types of those columns from the database, as well as the source and compiled code. And then the pièce de résistance, the lineage graph, the DAG that I was talking about earlier, auto-generated, inferred based on those ref calls and those source calls that I was typing just a few minutes ago. So these are, as I see them, the core features of dbt.